Good day everyone, we're going to take a look at exercise 67 from paragraph 7.5, and I think this is a rather difficult one if you do not see what you have to do, because I think there's only one way where you can do this quite quickly, and if you don't see that, then it's almost impossible to do this exercise. So let's take a look. Pen tool. They show us a rhombus, een ruit, A, B, C, D, with angle B being 130 degrees. That's that big one right here. Furthermore, this angle is 90 degrees, right? So that means E23 is also 90 degrees. And CE, this one is the bisector of angle C23. So those two are the same. We already indicated that. We only have to calculate one angle, E2, but to do that we have to use multiple intermediate steps. And that's why this one is also a bit more difficult, because they don't give us other angles to calculate beforehand. Sometimes it gives you some hint on in which order you can calculate the angles. Here they only give you one, and they say good luck with that. And if you get something like this, I can give you always a tip that if they say something like that, a rhombus or a parallelogram or a trapezium, sometimes you have to need that piece of information. In a rhombus, we know, for example, that all the sides are equally long. And that gives us a rather important piece of information here. I'm going to draw something. And I'm not going to say where I'm going to use it for, but maybe you can find it out by yourself after I have drawn it. I'm going to use this triangle, ABC. Why am I going to use that triangle? Can somebody find it out before I'm going to spoil it? Well, in this triangle, AB is equal to BC. So triangle, I'm going to write it down as well. Triangle ABC is an isosceles triangle, because AB is equal to BC, which means that angle A2 is actually the same to angle C23, right? It's going to be because of the isosceles triangle. Why does this work? Why does this help us? Well, we know that angle B, the vertex angle, is 130 degrees. So in that case, that is going to be angle A2 is the same to angle C23, which is the same as 180 of minus 130. That's 50 degrees, right? So A2 plus C23 is 50 degrees, but we have to divide it equally upon those two, which will give me 25 degrees for A2 and for C23. And we use the angle sum method for this. Angle sum triangle. In combination with the fact that those are base angles, you could say, you're using two at a time. If I now see through 2 and 3, I also know them separately, because C2 equals angle C3. So now, if I'm going to take a look at them separately, both of them should be 12.5 degrees. Which method did I use here? I used the bisector, right? Okay, and I think this was the most difficult part of this exercise, because if you have this, Now I think there are multiple ways to find the final answer. Let's take a look at how I'm going to do this. I think that I'm going to use this triangle right here, EBC. I can now calculate angle E3. And if I know A3 and I know E1, then I can calculate E2 by taking a look at the straight angle. So what I'm going to do is I say angle E3 equals 180 minus angle B, 130 degrees, minus angle C3, which is 12.5 degrees, which is going to give me the final sum of 37.5. Am I correct? I hope I'm correct. 50 minus 12.5. Yeah, it's going to be 37.5 degrees. And again, I use the angle sum of the triangle here. Which triangle? EBC. Triangle. Okay. So how can I calculate angle E2? Well, then I use the straight angle here, right? So E2 must be 180 minus angle E1, which is 90 degrees, minus angle E3, which is 37.5 degrees, right? And then you will find that angle E2 is not 60, but 52.5 degrees. And here I use the straight angle. Okay. I think if you want to do this exercise differently, I really think you need to use this information for this isosceles triangle, because otherwise it's very difficult to find different pieces of information here. I do think that you can also use a lot longer, I think, but angle D2 is 90 degrees as well because of this corresponding angle right here. So this is going to be 90 degrees. You could calculate angle C1 because C1 is going to be the same as A12, which I can calculate because there is a corresponding angle here. If A12 is something, C123 is the same as this minus 23, which was 25. And then I have this angle here. And I have this angle here, so I can calculate angle S2. I think this is a lot longer to calculate. From angles S2, I can calculate either S4 or S3. And then use the angle sum method here or angle sum method there. But I think that's a lot longer than how I did it. But it's an option either way. If you find on the test, it's still correct. Okay? Good luck.